Okay, we'll start with the next example on the Coin-Maklowski method. All of you take down this example, which is there on the board, right? So f of a comma b comma c comma d equal to sigma m 0, 1, 2, 3, 10, 11, 12, 13, 14, and 15, right? All of you take down this example and start solving. And someone should help me in solving it on the board. And then we'll see. Like first step is common, second step also is same. But if all the midterms are not covered in the prime implicant chart, what needs to be done? That is explained with the help of this particular example. Right? There are different ways in which it can be done. I'll tell you one simple way how we can take care of the midterms which are not covered by the essential prime implicant. Right? So for that, this particular example I have taken, it's an important example, right? So the midterm givens are already listed here: 0, 1, 2, 3, 10, 11, 12, 13, 14, 15. Is that fine? Is it visible now?
Yes, sir.
Okay, so write down all the midterms in binary form. All the midterms should be written in binary form. So you can help me. You can tell someone, you can help me what I should write, how I should write 0 now. 0 should be written as what? 0, 0, 0,
0,
0. 1
0.
should be written as 0, 0, 0, 1. 0, 0, 1, 0. 0, 0, 1, 1. 1, 0, 1, 0. 1, 0, 1, 1. 1, 1, 0, 0. 1, 1, 0, 1. 1, 1, 1, 0. And 1, 1, 1, 1. Right. These are the midterms given. I have written it in binary using the 4 variables A, B, C, D. Is it fine? This easily you can do it. What is the first stage now? In first stage, what I need to write? I have to rewrite these binary numbers which you have written here according to the number of what?
Once present.
According to the number of ones present. So what I should write first? Here I will get 0, 0, 0, 0. There are no ones. So I get first group. First group of midterms where there are no ones. Second group of midterms I have to write where there are single ones. So you write 0, 0, 1, 0. This I have taken, this I have taken, this I have taken. Then is there? Okay. There are only 2. Fine. Which are having single one. Then you should go for 2 ones. 0, 0, 1, 1. Then 1, 0, 1, 0. Then 1, 1, 0, 0. That's all. Right? Fine. Then 3 ones. You write this 1, 0, 1, 1. 1, 1, 0, 1. 1, 1, 1, 0. And lastly, what? 4 ones. So how many groups we got here? You can see we have a group containing no ones, we have a group containing single one, we have a group containing 2 ones, we have a group containing 3 ones, and we have a group containing 4 ones. This is a typical example where we can see here we have all the groups. Group with no one, group with single one, group with 2 ones, group with 3 ones, group with 4 ones. So totally 1, 2, 3, 4, 5 different groups we got. Is that clear? Yes? Any difficulty till this point? I hope there should not be any difficulty till this point. All of you understood this well? Is that fine? Yes or no?
Yes,
Now how to go to second stage now? What do you need to do in second stage? All these are covered here. Right. In second stage, first and second group should be compared. Then second and third group, third and fourth group, fourth and fifth group, and you may get there 4 different groups. So check now one by one. Can we compare this with this? Anyhow, one more thing I have forgotten. Here you can write these decimal representation also. This is 0, 1, 2, 3, 10, 12, 11, 13, 14, and 15. Fine. Next, what I need to do? As I said, you need to do comparison of one group with the next group. So do the comparison. 0 and 1 can be combined, and I can write this as 0, 0, 0 dash. I got it by combining 0 and 1. So I will take 0 and 1. Then 0 and 2 also can be combined, and I can write 0, 0 dash 0. This is I got by combining 0 and 2. Done. Then check 1 and 3 can be combined. This is one group. 1 and 3, 0, 0, 0, 0, 0, 1, 1, 1. So a single bit change is there. So that also I have 0, 0 dash 1. I got it by combining 1 and 3. Then different, same, different. 1 and 10 cannot be combined. 1 and 12 also cannot be combined. Then 2 and 3, yes, I can combine again. And I can write this as 0, 0, 1 dash. Got by combining 2 and 3. Then 2 and 10, is it possible? Different, same, same, same. Yes. Dash 0, 1, 0. This is by combining 2 and 10. And then 2 and 12, it's not possible. Different. So we got only this. Right. This is what we got. I have told so many times, you people join on time, but again in between you will disturb. Next, compare third and fourth group and try to check whether we can do the combinations or not. Now 3 and 11, is it possible? Yes, 3 and 11 can be combined, and I can write that as dash 0, 1, dash 0, 1, 1. That is 3 and 11. Then 3 and 13 is not possible. 3 and 14 is also not possible. 10 and 11 is 10 and 11 is, so I can write that as 1, 0, 1 dash from 10 and 11. Then 10 and 13, same, different, different, same. 10, 13 is not possible. 10, 14, same, different. Yeah, 10 and 14 can be combined, and I can write it as 1 dash 1, 0, 1 dash 1, 0 from 10 and 14. Then 12 and 11, 12 and 11, 1, 1, 0, 0, 1 different, they cannot possible. 12 and 13, yes. So 12 and 13 can be combined, and I can write dash dash 0, sorry, 1, 1, 0 dash 12 and 13. Then 12 and 14 also possible, and I can write that as 1, 1 dash 1, 12 and 14, sorry, 1, 1 dash 0, that is 12 and 14. Done. Next check, 11 and 15, is it possible? Yes, 11 and 15 is possible, 1 dash 1, 1, 11 comma 15. Then 13 and 15 is also possible, 1, 1 dash 1, 13 comma 15. Right. Then 14 and 15 is also possible, 1, 1, 1 dash 14 comma 15. I hope it is clear. All of you understood this grouping, how the grouping is done? Is that clear? All of you got the same?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, the same procedure you have to do. I said there is no change. Right now, can we go to the third stage? In fact, getting second stage is very important in all the examples. Once you get the correct second stage, third stage very easily you can get. Because I told in third stage what you need to do is only check the corresponding dash position and then only you try to do the comparison. Others comparison are not possible only. So check now. This you can check whether it can be combined with 0, 1, 2, 3. Can we combine 0, 1, 2, 3? Same, same, different, same. Yes. So 0, 1 and 2, 3 can be combined and I can write that as 0, 0, dash, dash. 0, 1, 2, 3. Right. So no other thing is possible. Leave it. Then take this and check whether 0, 2, 1, 3 can be combined again. Yes. So that is 0, 0, dash, dash, 0, 2, 1, 3. So 0, 2, 1, 3. That is done. So this is one group. So comparison is over. You need not check. This and this comparison is done. Now we have to compare this group with this. Take one by one. This 1, 3 can be compared with what? Can I compare 1, 3? Just check whether it is possible with this or no. Can I combine this and this? No, because here 2 zeros are there, 2 1s are there. So 1, 3 cannot be combined with anything else. Then check 2, 3. 2, 3 can be combined with the 10, 11. Different, same, same, same. So 2, 3, 10, 11 can be combined. And I can write that as dash 0, 1 dash 2, 3, 10, 11. Then check 2, 3, 12, 13 can be combined. Here 2 zeros, 2 1s, no, because only 2 positions here. Then check 2, 10. 2, 10 and 3, 11 can be combined. Yes. 2, 10 and 3, 11 can be combined and I can write dash 0, 1 dash. That is 2, 10, 3, 11. So this and this comparison is done. Now take this 3, 11. Can we combine with anything here? No, because here dash is there, here no dash is there. Then here dash is there. Can we combine with this? 10, 11, 14, 15. Same, different, same, same. So 10, 11 and 14, 15 can be combined. So this is second group. Right. So 10, 11 and 14, 15, it becomes 1, what? Dash, 1 dash. 10, 11, 14, 15. Right, 10, 11, 14, 15 done. Then 10, 14 and 11, 15 can be combined and I can write that as 1 dash, 1 dash. That is 10, 14, 11, 15. 10, 14, 11, 15. Right, done. Now this 1, 1, 0 dash, that is 12, 13. 12, 13 and 14, 15 can be combined and I can write that as 1, 1 dash dash 12, 13, 14, 15. Right? That's 12, 14 and 13, 15. 12, 14 and 13, 15 can be combined and I can write this as 1, 1 dash 1. So it is 12, 13 and 12, 14, 12, 14 and 13, 15. 13, 15. That. Okay. So after comparison of second stage, we got third stage. Now you should check further. Normally, we have a tendency to stop at third stage only, but by default, you should not stop there. You should check whether fourth stage is also possible. So you can check here. Comparison is not possible only because here as well as here we don't have. Similarly, here we don't have, so there is no possibility of doing any comparison. Right? We can stop here. I hope all of you got this. Right? So what you can see from this is 0, 1, 2, 3, 0, 2, 1, 3. So you should take 1 because these two are same. These two are same, you should take 1. These two are same, these two are same. So totally, how many prime implicants we are getting from this? Totally, how many prime implicants we are getting
4.
from the first step of Cohen-Macklinsky method?
4.
Yes?
4.
4.
Yes, am I audible? Am I audible?
Yes,
Yes,
sir.
sir.
Board is
Yes, sir.
visible? Board also visible? Yeah. So how many prime implicants we got then? Totally, how many prime implicants we got?
4.
4 prime implicants. So we have to construct prime implicant chart now. Can I construct prime implicant chart?
Yes, sir.
So I will construct the prime implicant chart. Yeah, the board is visible now.
Yes, sir.
Yes, sir.
Yeah. So what I did is, I think there was in between some network connection. But anyhow, I have not explained anything during that period. I have just written all the prime implicants which we have got from the first stage. I have listed here. That's all, right? So you can see here 0, 1, 2, 3, 0, 2, 1, 3 same. So I have taken one from this one, from these two, that is one, and from these two, it is one. And I have written it in terms of the literals A, B, C, D, or in terms of the variables A, B, C, D. Is that clear? Is that clear? What I should do next? Next, corresponding to these minterms, you have to put the x. So 0, 1, 2, 3. 0, 1, 2, 3. Next is 2, 3, 10, 11. Next is 10, 11, 14, 15. 12, 13, 14, 15. 12, 13, 14, 15. So corresponding to those minterms which is covered by the prime implicant, I have put X. Right. What is the next step? What is the next step now?
Circle the single X.
Single X in a particular column. So how many X are there in the first column? How many are there in the first column? Yes, Kedar, you can help me. How many X are there in the first column?
1.
1. What I need to do? I should circle this. How many are there in the second column?
1.
So this also need to be circled. How many are there in third?
2.
That is into 2. So no. Here how many are there?
2 again.
Here 2, 2. Here
1.
1. So that needs to be circled. Here how many are there?
1 again.
That needs to be circled. Here, here.
2.
So after doing that circling of the square, whichever row you find that is essential prime implicant. This is essential, right? And this is also essential. Wherever you find that circle, whether one circle, two circle in a row, that particular prime implicant is essential prime implicant. Is that clear? Right. So normally you will try to stop here at this position, right? But you should not stop. You should check how many prime implicants, essential prime implicants we got here now. Totally 4 prime implicants we got. Out of 4, by this method, now we have got only 2 are essential one. Which are the 2 essential one? A bar, B bar, and AB. Right. So before you accept them as essential one, you need to check whether those 2 prime implicants cover all the minterms or not. Now this particular prime implicant, it is covering which all minterms? Yes, Kedar? Which all minterms?
0, 1, 2, 3.
1, 2,
2,
3. And this is covering what?
12, 13, 14, 15.
12, 13, 14, 15. Right. So what is happening here is we got 2 essential prime implicants, but they are not covering what? All the prime implicants. 2 are left. You can see here. 10 and 11 are left. So now how to cover those 10 and 11? This is very important question now. Can anybody help me? Like all prime minterms are not covered by these 2 essential prime implicants. So what we need to do to cover these 2 prime implicants, 10 and 11 also? Yes. So for that, you should
We can
check
change the
remaining prime implicants which are there. You should check. If I take a particular prime implicant, whether it covers both the remaining minterms or not. It is like a trial and error method you can use, and you should see that you will cover those 2 also. Now, which are the remaining one? This and this. Is that clear? So if I take which out of these 2, I am able to cover the minterms 10 and 11. Yes. Now you have to decide whether I should use this or this. There is a question mark. No. I need one more. 2 essential I got, but they are not covering all the prime implicants. So your duty to check out of these 2, can I take any one or both, and I will be able to cover the remaining minterms. So what I need to do now? Yes. If I take, say, this 2, 3, 10, 11, whether I am able to cover 10 and 11? Yes. Are you getting my question? If I take this as essential one now, can I cover 10 and 11 or not? Or if I take this, can I cover 10 and 11? Yes? Yes, Danishwari?
yes, sir.
Which like the remaining prime implicant covers 10 and 11 minterms? These 2 are essential. We have to take these 2. But by taking only these 2, we are not getting the optimized solution. We need to take some other prime implicants also. So what I should take? Whether I should take this or this, that is the question now. These 2 are decided already. We have to use them compulsory. But by using only these 2, I am not able to cover all the minterms. So what I need to do? I need to take some additional prime implicants and you have to make them essential. So which additional prime implicant I should take it as essential prime implicant? Yes?
Sir, either of both of them have 10 and 11. You can take either of
Yes,
them.
so we can take any one, not both. Is that clear? I can go for this or I can go for this. So I can take either this or this because it will cover the remaining two, that is 10 and 11. So to cover this 10 and 11, I should go for either this prime implicant or this prime implicant. Hence, I can write the answer F as these two are fixed. A bar B bar plus AB plus what? I can go for what? B bar C, or I can write F equal to A bar plus AB plus AC. So there are two answers. If you add this prime implicant, you will get the first answer. And if you add this prime implicant, you will get the second answer. So here, for this particular example, we have got two different answers. I hope it is clear. All of you understood this. In fact, in the homework problem also, I have given one similar thing. I don't know how you have done that. So you should not go with only which are star. Those are essential prime implicants. You have to check for one more condition. That is, the chosen essential prime implicant should compulsory cover all the mean terms. If the essential prime implicants have not covered all the mean terms, then you have to use additional essential prime implicants. That is the very important thumb rule you have to remember here. Is it fine? Is that clear? Any doubt here? Right, this is very important example. If you have any doubts, you can ask me now itself. Is it clear? Yes, Shreya, are you there?
Yes, sir.
Understood?
Yes, sir.
Because you are the only person who has asked me the doubt in that homework problem. I don't know about others, how they have done that homework problem wherein such a situation has arisen. I hope your doubt is clear now, Shreya?
Yes, sir. Yes, sir. Yes.
Yes, any other doubts anybody is having? Clear? Shall we go ahead?
Yes, sir.
Yes. Okay, I'll give you another example now. All right. So here you have got two answers: A bar B bar plus AB, that is must, plus B bar C or plus AC. Those are the two different solutions that you will be getting for this particular example. Right. So I'll give you one more example. All of you can do it. Do it as a homework. Take it. Simplify the following expression using QM method. Simplify the following expression using Cohen-McCluskey method. Using Cohen-McCluskey method. F equal to pi m, F equal to pi capital M. What that pi m means? Yes. I told you have to take this F equal to pi m of 1, 3, 1, 3, 6, 9, 1, 3, 6, 9, 11, 12, F equal to pi m 1, 3, 6, 9, 11, 12. Okay, this is what we have to simplify using Quine-Maklowski method. So what you need to do here? How do you go about this particular example? If you remember in the very first class of Quine-Maklowski method, what I told you people? The
It is
Quine-Maklowski
applicable only for
method can be applied only for
SOP.
SOP expression, but the given
SOP
expression
form.
is in which form?
POS.
QoS. So what you should do
QoS.
before you apply QM method?
We
You have
can
to convert
convert
this
it to
into
Convert
SOP. How do you convert this into SOP now? So pi m is given, you have to get sigma m. How do you do that?
remaining
What do you
terms.
do?
We can
Yeah, remaining terms.
Remaining
So how
terms
much you
of
write? 0, 2,
0,
4, 5,
4,
7,
5,
8,
7,
10,
8, 10,
13, 14,
13, 14, 15.
0, 2, 4, 5, 7, 8, 10, 13, 14, 15. Right. This is the expression given to you using which you can, what you can do? You can apply the QM method and you can get the answer. Right? Fine? All of you understood it?
Yes, sir.
Okay, I'll give few more examples as a homework examples. All of you should do it. You can take down this. F equal to sigma m 1, 3, 5, 4, 9, 10, 11 plus sigma d 6, 8. Already I have explained you, if there is a don't care, what you should do. Don't care should be taken as it is in the first step. But in the second step, when you are going to construct what? The prime implicant chart, there it should not be considered. There it should not be considered. Is it fine? So I'll give one more, which is appeared in the September 2020 examinations. You can have this. F equal to pi m. F equal to pi m 0, 1, 6, 8, 0, 1, 6, 8, 11, 12, 0, 1, 6, 11, 12 plus don't cares 3, 7, 4, 50. Correct? You can use Quine-Maklowski method and you can get the answer for this. Right? So you can try one more. F equal to sigma m. F equal to sigma m 6, 7, 9, 10, 13 plus sigma d 1, 4, 5, 11 and 15. 1, 4, 5, 11, and 15. Right. So some more examples you can refer any of the textbook, and you should able to solve these different kinds of example on the Coin-Maklowski method. So will you able to do these homework problems given to you?
Yes, sir.
Yeah. So now there is one more method actually called Patrick's method, which can be used to solve or to overcome the difficulty what we have faced in the previous example. If there are more than a few minterms are not covered by the essential prime implicants, then those can be covered by the trial and error method, or there is one more method called Patrick's method. Anyhow, in the notes and the PPT which I have shared with you, in that Patrick method is explained. Just here I will show you the same quickly, so that sometimes they will ask explain Patrick method. So you should able to explain with the help of example what is that Patrick method is. All right. I hope the screen is visible to you. Of course, it is a handwritten one, scanned copy. Is it visible?
Yes, sir.
Yeah. You can see, suppose if you come across such type of prime implicant chart. What is this speciality of this prime implicant chart? I given you one example. In fact, if you take this example, f equal to sigma m 0, 1, 2, 5, 6, 7, you can take it as a homework and you try to do this example, right? You will come across this type of prime implicant chart. Now, what is the speciality of this prime implicant chart? Yes? What you can observe from this prime implicant chart? Can anybody comment on it?
No, there is no single X.
Yes, exactly. If you see here, there is no column containing single X. That means we will not able to get any of these prime implicants as essential prime implicants. In fact, how many prime implicants are shown here? 1, 2, 3, 4, 5, 6. Totally 6 prime implicants are shown here. Right. So none of these 6 prime implicants are essential. Then how to overcome this difficulty? That's where the Patrick's method will come into picture. So what is this Patrick's method is? It is a very simple method. So in the Patrick's method, when you want to apply, you have to mark all the prime implicants as P1 to Pn. Here there are 6. So first prime implicant we have marked it as what? P1, P2, P3, P4, P5 and P6. Right? Is that clear? Now, using these 6 prime implicants, we have to arrive at the essential one. So for that, what you have to do is take the OR operation of 2 consecutive prime implicants, P1 and P2. That is P1 or P2. Then P2 or P3, P3 or P4, P4 or P5, and P5 or P6. OR operations you should take of the 2 consecutive prime implicants, and then you need to take AND operation of all. So you can see here I have written P1 or P2 and P1 or P3 and P2 or P4, right, and P3 or P5 and P4 or P6 and P5 or P6, right? Then you have to simplify this. Use the laws of Boolean algebra. You try to simplify it. P1 plus P2 into P1 plus P3 can be written as P1 plus P2 P3, like the distributive law, right? You can use here also, you can use this distributive law. For this you can use the distributive law. So you got P1 plus P2 P3, P4 plus P2 P6, P5 plus P3 P6. Then again apply what? The same. The multiplication, you can multiply these 2 terms, P1 P4, then P1 P2 P6, P2, P3, P4, P2, P3, P2, P6, like that. Simplify, and finally you will come across this, right? So finally, when you come across this, what it means? You can take combination of what? Either P1, P4, P5, or P1, P2, P5, P6, or P2, P3, P4, P5, or this, right? So wherever more number of terms are there, you remove that, that is ruled out. So 4 are there, this should not be used. Like here also 4 are there, this should not be used. Here also 4 terms are there, this should not be used. So here and here, there are only 3 terms. So you can take either this or this. P1, P4, P5 means what? You can see here. Take this P1, P4, P5. That is A bar, B bar plus B, C bar plus AC. That is one answer. Or another answer is P2, P3, P6. That is A bar, C bar, AC and AP. Like this, you should able to solve this. And that is what is called as the Petrik's method. And as I said, Petrik's method can be summarized. It is reduce the prime implicant chart by eliminating what? The essential prime implicant rows and the corresponding columns. Like if you have already got some essential, we have to remove those and retain only those which you have not yet found as essential one. Then label the rows of the prime implicant chart as P1, P2, P3. Then form a logic function P which is true when all the columns are covered, which consists of product of some terms. And then simplify that P, and each term in the result represents a solution. To determine minimum solution, find those terms which contain minimum number of variables so that each of these terms represents a solution, right? That is how you need to apply what is called as the Petrik's method. If you are not able to solve that example by trial and error method, you can go for the Petrik's method. I hope the Petrik's method is also clear. It is simple. In the PPTs also already I have mentioned. I think already you might have gone through that. See, in the PPTs also the same thing was explained. This is what is there in your PPTs. Petrik's method. The summary of Petrik's method is given here. You write P1, P2, P3, then take the OR operation. Like the same example is given here. 0, 1, 2, 5, 6, 7, whatever the example I have taken there, the same thing is explained here again, right? And how you get those two solutions, that is what is given in this particular Petrik's method example also. So you have to use the Boolean simplification technique to simplify it, and minimum terms you should take out of it. See one more example. Here 3 are there, here 3, then 4, 5, 4, 4. So this should not be taken. So either this or this can be taken as the solution for the Petrik's method when you want to determine the essential prime implicants from the prime implicant chart where it is not possible to find those essential prime implicants by what? The method of inspection. I hope that method is clear. All of you understood that? All of you understood it or no? You need to work out that. It is there already. I have shared with you the notes as well as PPT. Just go through that, right? Other examples also you need to solve on the prime, that is Cohen-McCluskey method. I request whatever homework problems I have given, you solve all those. In addition to that, few more examples also you need to solve. If you have any difficulties, you can approach me anytime. So with this, we'll close the discussion on Cohen-McCluskey method. In the next class, we'll quickly discuss about the map entered variable method, and maybe 1 or 2 examples, additional examples we'll solve. And in the next class, we'll be closing the discussion on module 2, right? So I hope all of you understood the K-map method and the Cohen-McCluskey method, also the Petrik's method. In the next class, I'll be telling you one more simple method of simplification of Boolean expression called map entered variable method, right? So what is that map entered variable method? That we'll be discussing in the next class. So before we close the